Hello, I'm Dylan Beach. I go to school at Makua Christian Academy, and I am a junior there. My goal is to implement green energy onto the space elevator, and a quote that inspired me onto this mission was from Peter Swan, PhD, from the ISAC organization website. The quote reads as follows: "We are on the brink of transforming our relationship with space, offering an eco-friendly, cost-effective, and efficient logistics method to transport large cargoes into space. This gateway will provide unparalleled opportunities in space exploration, resource utilization, and satellite assembly." So to summarize with what I did to the space elevator, I put a 2-tank indirect thermoelectric storage system as a non-green battery alternative and used solar panels to produce energy for that system. This was done to keep our atmosphere healthier and be a pillar to humanity, showing green energy as a power source of the future. So for the elevator itself, it would run on its own using an AI system, bringing drones up and down from space, which would also be carrying people and resources from and to Earth. It would connect to Earth from the water by the equator with a cable made out of tungsten, which is not recommended because there are wires being researched which would be stronger and cheaper than tungsten. The picture on the right here is made by me in Canva. It shows where it would connect to Earth on the water, the wire running up to the geostation, and the pods going up and down. And then this picture on the side here would be the storage system with the solar panels running to it, and then the storage system storing the energy and then sending it back through the solar panels. So the benefits of having a space elevator would be cutting down the cost of bringing supplies to space and back to Earth. It would also require less training from astronauts because they don't need to learn how to use spaceships, and also they wouldn't need as much physical training to get to space. Money from the public could be earned from the space elevator by making it into a form of hotel for some sections, and it would allow us to teach people more about space and space programs. Bringing people to space, too, also would boost the morale of astronauts' families and the astronauts themselves by letting them actually talk to each other while they're away on mission. The traveling to other parts of space is also an option, too, because you can launch from the geostation to, let's say, the moon or Mars. It would be using less rocket fuel because you're closer to them, and you'd also be keeping that rocket fuel farther from our atmosphere. So for the first part of my implementation to the space elevator would be the solar panels added to the geostation. This would add a positive green energy to the geostation, but for it to run, we need about 10,000 joules for every 1,000 kilograms on board of that geostation. This would mean we need about 25 solar panels for every 1,000 kilograms, which is possible for how big the geostation would be. And then, of course, these solar panels would be connected to the thermal electric storage system to keep it running. So for how the thermal electric storage system works, it's a 2-tank indirect system that uses 2 different fluids for storage and heat exchanging. In this system, there are 2 heat exchangers for each tank. The storage fluid from the cold tank goes into the heat exchanger to be warmed by the heat transfer fluid. It then sends the fluid to the hot storage tank. Then the liquid from the hot storage tank goes into the extra heat exchanger, which produces the electricity. This system most commonly uses organic oil for heat transferring and molten salt for storage liquid. Water can also be used as a transfer liquid, and soil, gravel, or lunar regolith can be used as storage materials. While the heat is stored in a material, it can be turned into steam. This steam would go into a turbine, spinning it to produce electricity. So here we can see the organic oil over here, and then we also see the molten salt for the storage liquid and then the heat transferring liquid. Here would be the example of the layout for the thermal system. It would be the solar panels going to the hot tank and then to the boiler to go into the turbine, which would spin the steam into electricity. And then once it's cooled down, it would return to the cool tank to be warmed up again by the solar panels, repeating the process over and over. This image here is made by me, and then these two over here are public domain. So for materials for the thermal electric storage system, we could use many materials like soil or gravel. Some fluids also work in the system like water. Lunar regolith is even a possible material. The only problem with lunar regolith is that it is expensive to go to the moon and back, bring back tons of lunar regolith, and also dangerous with how lunar regolith works. This is because these materials hold heat very well, is why all these materials are open to the system. For this project, I chose the molten salt for our storage fluid and then the organic oil for the heat transfer to bring into these systems. I made this decision because of the newly formed elevator. It would be easy to bring these materials up for cheap, being around $100 a pound. So for the operation of the space elevator, we could use the extra energy stored in the storage system to be transferred to Earth through microwaves. There would be an antenna array on the geostation, which we could beam down microwave energy onto a ground station or retina. Once received, the microwaves can be turned back into energy on Earth to be used as clean energy. To track how well the system is doing, we can look at how much heat is stored in the system, how much solar energy is collected by the solar panels, or the microwaves sent back to Earth. Another potential way to track our progress would be an economic boost from the space elevator if we choose to make it into a hotel and let the public go up to the geostation. So now let's talk the benefits of the thermal electric storage system. It's a green way to hold energy, unlike standard batteries. And unlike standard batteries, they last decades compared to their years of functionality. It also has a higher energy density than most hydroponic dams, which means it can hold more energy in less space. And this also is cheaper than most electrochemical batteries, which is surprising. Along with everything I've thought of for the space elevator, there's many other ideas that the space elevator can do to contribute to humanity. As Peter Swan, the PhD from ISAC organization said, it has the potential to unlock solutions to Earth's most pressing challenges, such as harvesting solar power from space, which is, I suggested a way to do that, climate monitoring, that's something I didn't think of, and global communication networks, which also I did not think of. So to conclude the space elevator and this video, it is important to understand how the elevator will affect humanity. This elevator will help humanity by cleaning the atmosphere of rocket fuels and replacing them with the space elevator powered by solar energy. Not only can the space elevator clean our atmosphere, but it also has the potential to clean up Earth itself by being a beacon to humanity to learn from. Thank you for your time and have a great rest of your day. We'll follow this is all the sources I used for this project.